We're going to review factoring right now. Factoring is a concept that we spent a very long time on first semester, and it is going to be something that we are going to be doing a lot with this semester. So when it says, what is our first step when factoring, we always want to look for a GCF. Remember, GCF stands for greatest common factor. We're looking to see, are there any numbers? And if there are any numbers, what's the biggest number, as well as variables that they have in common. So let's factor completely. We have x squared plus 12x plus 35. So when I start looking for a GCF, I notice that right away, there's a 1 in front of the x squared. When there's a 1 in front of any of these terms, that tells us that 1 is going to be the biggest number that we can take out. So because 1 is not going to then change anything, there's not going to be a number that they all have in common. I also noticed that the very last term, 35, doesn't have a variable. So if there is no number in common and they don't all have a variable, that means that there is no GCF. So then the next step is, because there is a 1 in front of the x squared and there is no GCF, I get to follow the pattern of asking myself, what is going to multiply to the last number but add to the number in the middle? So I'm going to make a chart of numbers that multiply to 35, and I want to add them up and see if it gets me 12. So you can go down the list. Obviously, 1 times that number is going to get you 35, but notice that if I try to add those, it's going to get me 36, which is definitely not that 12 in the middle. But if you use your if you use your multiplication chart, or if you use your calculator, you'll see that 5 times 7 multiplies to get 35. And if I add those two numbers, it's going to get me the 12 that I'm looking for. So that tells me that these are the two numbers that I want to use in my factored answer. So remember, to factor means that we are looking to create two things that are multiplied together. Because there was a 1 in front of the x squared, that means that we get to start each of our parentheses with an x, because x times x is x squared. The two numbers that worked, that multiplied to 35 but added to 12, so the 5 and the 7, those are what's going to fill in the rest of the parentheses. Everything's positive in my original problem, so everything's going to be positive in my parentheses. It doesn't matter if you put the 5 first or the 7 first. I'm just going to put the 5 first, but then this would end up being my factored answer. If I take a look at the next problem, x squared plus 4x minus 32. Once again, I notice that there is a 1 in front of the x squared, which means that I'm not going to be able to get a number other than 1 out of this trinomial. So I don't have a number in common. That negative 32 doesn't have any variables. So once again, there is no GCF here. And since there's a 1 in front of the x squared, we get to follow the pattern of what is going to multiply to the last number, but add to the number in the middle. So now this is where you just got to be careful. We have to keep the negative sign with the 32. So if I'm starting to think about numbers that multiply to 32, but they has to be negative, that means that one of my numbers has to be positive and one of my numbers have to be negative. So if we start thinking about numbers that multiply to 32, well, there's a lot of numbers that do. Notice that, it's an even number, so 2 is going to go into it. And if I make the 2 positive, that means the 16 has to be negative, because 2 times negative 16 will get me negative 32. But notice that if I try to add those numbers, it's going to get me negative 14. Even if I flip those signs around and the 2 is negative and the 16 is positive, it's still not going to get me to that positive 4. So 2 and 16 aren't going to work. So what are some other numbers? Well, 4 and 8. One of these has to be negative. If I make the 4 negative, notice that when I add negative 4 plus 8, that will get me my, that's going to add up to get me my positive 4. That's what I'm looking for. So a positive times a negative, those two numbers multiplied to get me negative 32. And when I added them, it got me that middle term of positive 4. So those are the numbers that I know need to go in my final answer. Once again, because I have a 1 in front of the x squared, I get to start each of my parentheses with an x. The negative has to be with the 4. So I don't care if you put the 4 first or second. I'm going to put it first, but it has to have a negative sign with it. The 8 is positive, so that has to be a plus sign. This would be my final factored answer. Okay, if I keep looking at some of these examples, we have x squared minus 16. So I want to look for a GCF. I notice that there is a 1 in front of the x squared, so 1's the biggest number we can take out, which is not going to change anything. 16 doesn't have a variable, so once again, there is no GCF. But notice that this time, this problem is different than the first two examples, because in the first two examples, we have an x squared, an x, and a number. There's 3 terms there. Here, we only have 2, an x squared and a number. So remember from last semester, I can make it 3 terms. I'm missing that middle term of x, so I can put a 0 with it. And then we are doing the same thought process. I want to know what's going to multiply to a negative 16 but add to 0. So if it needs to multiply to a negative, just like that last problem, one of my numbers has to be positive and one has to be negative. But think about this. If it needs to add to 0, there's a couple ways to multiply to 16. But if you want it to add to 0, that means it has to be the same number, but the signs have to be opposite. So what's the same number to multiply to 16? Well, that's 4 and 4. If one of them is positive and one of them is negative, it'll multiply to that negative. Notice that when I add these two numbers, it gets you that middle number of 0. So 4 and negative 4 are the numbers that I want in my parentheses. So parentheses, once again, are going to start with x's because x times x will get me that x squared that started us off. One of the parentheses has to have a negative 4, and one of them has to have a positive 4. And that'd be my answer. If we look at this next example, we have 3x squared minus 15x minus 42. Notice that this time I see a number in front of the x squared. So because 3 is the smallest number, let's see if we can get a 3 out of everything. So if I break these down, 3 times 5 is going to get me 15, and 3 times 14 will get me 42. So notice that they do all have a number in common. That means we have a GCF. Because that last term doesn't have a variable, I don't have an x that they all have in common. So looks like 3 is the GCF. So I put the GCF on the outside, and now in parentheses, I need 3 things left over, but that 3 from the GCF needs to be taken out. So if the first term is 3x squared, but I took out the 3, that means I'm left with the x squared. I'm going to bring down the subtraction sign. I can ignore the 15 because that was 3 times 5. I took out the 3, that means I'm left with the 5. There is an x in the middle as well, so I have to continue to have that. I'm going to bring down the subtraction sign. We can ignore the 42 because that was 3 times 14. If I take out the 3, I'm left with, the 14. Okay, so there's the first half of our factoring, but the directions say factor completely. That means x squared minus 5x minus 14. Notice because now there's a 1 in front of the x squared, we can follow the pattern. What's going to multiply to negative 14, but will add to negative 5? So if I'm thinking about numbers that multiply to negative, I know that one number is positive and one number is negative. There's only a couple ways to multiply to 14. But if I do negative 7 times positive 2, that will get me my negative 14. And then when I add those two numbers, I will get that negative 5 from the middle. So once again, I know that those are the two numbers that need to be in my parenthesis. But this time I have this GCF of 3. I cannot lose that. So the 3 is going to start us off, and then we'll have our parentheses. So I bring that GCF down, And now I'm back to, I can start each of my parentheses with an x because we had that 1 in front of the x squared inside that parenthesis. And then the -7 and the +2 will fill out the rest. So this would be my final factored answer. Okay, if we look at the next example, 3x squared minus 14x minus 5. Notice that with my numbers, 3 is the smallest, but if you try to break it down, there's not going to be a number that multiplies 3 times something to get 14, and same thing with 5. 3 times a number will not get me 5. Because 3 is what we call a prime number, which means the only way to multiply to 3 is 1 times 3, that means I don't have any numbers in common. And the 5 doesn't have a variable, so there is no GCF here. So how are we going to factor if there's not a 1 in front of the x squared? This is where that guess and check process comes from. I start with the 3. We know that that's 1 times 3. So when I'm thinking about starting my parentheses to do the factoring, one of the x's will have a 1, but the other x is going to have a 3 because 1x times 3x will get me that 3x squared. Then I move over to the last number. It is -5. So I need to think about all the ways to multiply to -5. That would be a -1 times 5, or that would be a 1 times -5. This is where the guessing comes into play. But I need it to then add to the middle number. So we need to pick one of those two options of numbers to multiply to -5, plug them in for the rest of our parentheses, and then we'll check to see if it gets that -14x. Okay, so I'm going to try -5 in the first parenthesis and a +1 in the second. So there's my guess. Now my checking means that I'm going to multiply the outer terms together and the inner terms together. So 1x times 1 is 1x. -5 times 3x is -15x. If I combine those like terms, well, look at that. It gets me the number that I'm looking for. It gets me -14. That tells me that I guessed correctly right away. And so then I can just circle that and it's my answer. If I didn't get -14x, that's okay. Then just maybe switch the numbers around and then try it again. So that's why it's called guess and check. You guess, you might not always be right with your guess, but that's what the checking is for. Okay, last example here. We have 5x squared minus 7x plus 2. If I want to look for a GCF, 2 is the smallest number, but notice that I can't multiply 2 times something to get 5. I can't multiply 2 times something to get 7. And 2 is one of those prime numbers. It's just 2 times 1. So there's no number that they have in common, and I see because the 2 doesn't have a variable, once again, there is no GCF. But because there's that number in front of the x squared, we have to do that guess and check like we did in the last problem. So I look at the 5 and I'm asking myself, how do I multiply to 5? Well, that's 1 times 5. So remember, when I'm starting my factoring with my parentheses, I have to have a 1x and I have to have a 5x that starts this process. Then I move to the last number. I need to find numbers that multiply to 2. Well, like we said, that's 1 times 2. But now here's the thing. Notice that what I wanted to add up to is a -7. So if I want to multiply to a positive, but get it to add to a negative, 2 positive numbers is not going to make that happen. However, 2 negative numbers multiply to get me a positive as well. So -1 and -2. So that's going to be the only option. It's just a matter of which number goes in the first parenthesis and which number goes in the second to get us to that -7x. So I'm going to just do -1 and -2. I'm going to put them in that order. So there's my guess. Now I'm going to check. So remember, I'm going to multiply the outside terms together. 1x times -2 is -2x. Then I'm going to multiply the inside terms together. -1 times 5 is -5x. When I combine those, notice that right off the bat, once again, I was able to luck out. It got me what I wanted in the middle. So my guessing was correct. If it wasn't, then you just have to try it again. But there is my completely factored answer.